Yeah, can you see the screen, ma'am? Yes, guys. Can you see my screen? Can you please confirm?
Yes, sir.
Thank you. In the previous class, we have seen about the important cursors. So there are three important cursors available. The cursors are also called as iterators. So the first cursor is enumeration. Enumeration is one cursor. The second cursor is iterator. The third one is list iterator. Enumeration can be applied only for the legacy classes. The second one, the iterator can be used for, iterator is a universal cursor. You can apply for any collection object. The third important cursor is list iterator, which is applicable only for the list implemented classes. You cannot use it anywhere. Wherever you like, you cannot use it. But can you, if you observe what is the universal cursor, iterator is the universal cursor. Enumeration is the legacy cursor. And then list iterator is an advanced cursor, but only applicable for this list implemented classes. And if you observe the properties of iterator, list iterator, and then enumeration. So in the enumeration, okay, enumeration has only forward movement. There is no backward movement for this cursor. Okay, and even you cannot remove any element from any position if you want, right? You cannot delete that. You cannot modify anything from the existing, right? So existing collection object by using iterator object also. So you cannot, you can remove the elements at some position, but you cannot modify that element. It means you cannot replace the element. So the third option, like list iterator, so you can modify, you can move in the forward direction, you can move in the backward direction also, and you can modify an element at some at a particular index. So you can delete an item at the particular index, you can add an item at a particular index. So all these operations you can say, and then the best iterator for the best iterator available for the list implemented classes, that is list iterator, right? So these features you can use based on your requirement. But so if I have requirement somewhere else, like I cannot use the list iterator, this list iterator cursor. List iterator cursor cannot be applied on so the other the other objects like tree set. I mean, if it is not the list implemented class, you cannot apply that. Remember that way. Okay, list iterator is only for list implemented classes. Okay, it cannot be used by any other objects. Okay, enumeration only for legacy classes. The iterator, you can use it as a universal cursor. And you have seen some methods in each of them. And this table also you have seen, right? So a lot of methods available for the list iterator. And then, so the only three methods for the iterator, and then only two methods for the enumeration, right? And this you remember, this is very important in the examination point of view and the interview point of view. And see, we are looking at the set interface. The properties of set interface is, this is the set interface is child interface of collection. So if you want to represent the individual elements as a group where the duplicates are not allowed and insertion order is not preserved. Remember, duplicates are not allowed, insertion order is preserved. So we have gone through only two interfaces so far. I mean, this we are studying, and then we have completed one interface, that is list interface. So for the list interface, you have more two important properties where insertion order is preserved, and then so duplicates are allowed. So in the set interface, duplicates are not allowed, insertion order is not preserved. Okay. So remember these 2 points. If your requirement is this, and you can come here, the set interface. Right. In the set implemented classes, so your set interface is directly a sub interface of correction interface. And then there are two classes, which I mean three classes which are implementing the set interface. One is hash set. So the second one is linked hash set. The third one is tree set. Remember? So what are the, so you may ask something like explain about the set implemented classes. So that time you have to explain about hash set, linked hash set, and then tree set. Only three classes. So there you have four classes. What are those four classes in case of list interface, array list, linked list, vector, stack. 4 classes there. Here you have only 3 classes, that is hash set and the linked hash set, which is a subclass of hash set, and then it is preset, which is implementing so sorted set interface and then this navigable set interface. Okay, the tree set is implementing 2 interfaces, so it means 3 interfaces it is implementing. So navigable set interface, sorted set interface, and then set interface. Okay, only tree set is only the class implementing this. So if you keep this in your mind, then we go on. Right. So the first class that is implementing this set interface is hash set. So the properties of hash set is underlying data structure is hash table. Okay, underlying data structure is hash table. So here anyway the properties of set interface is held by the hash set also, and then insertion order is not preserved, and then duplicate objects are not allowed. So these 2 properties are anyway will be there for the hash set also. Okay, so these 2 properties are very important. Insertion order is not preserved, duplicate objects are not allowed. And important is heterogeneous objects are allowed. Null insertion is possible. You can insert the null element into this. There is no problem. And then if you are trying to add any duplicate objects into this collection object, so you will not get any compile time exception or runtime exception, but it is going to simply return you true, false. Only that. So the add method. So only heterogeneous. I mean, if you are duplicate objects are not allowed. If you are trying to add any duplicate object, you will get the but no exception at either at compile time or runtime. So but it simply returns the false. Okay. So what is the hash code and so how the elements are going to be stored if the insertion order is not preserved? Then how the elements are going to be stored inside this collection? So you already know this data structure hash table, right? So the hash table is something like this. You will have a hash function. So for example, we have assumed that you have 3 locations here. So my hash function is equal f of x equal to it is something like x modulo 10. Okay, assume it is x modulo 10. Okay, so the x modulo 10. So for example, these are the slots. We call them as slots 1. So these are, so otherwise you call them as buckets. 3. If a number 20 is, 22 is given, so where I can store this data inside my table, right? So it is 22 modulo 10. So so the 22 will go to the location 2. And then if I give some element 11, so where it will go? It will go to a position 1, right? So and then if I give something like 33, it will go to a position called 3. This is how the elements are going to be stored inside the hash table. So what is the importance of hash table, you tell me? So searching is the complexity of this hash table is order of 1. So if I ask you where 22 is stored, directly you can, by using your hash function, directly you can go to the location and fetch it. It means it's order of 1 only, right? So the best algorithm where you can retrieve the element with order of 1. So the best time complexity is given by this. So that's why, so this hash table is used as an underlying data structure for the hash set. Okay, this underlying data structure for this hash set is what hash table concept is used. The insertion order is not preserved, we have seen. So if the insertion order is not seen in this, how the elements are going to be stored? So the elements are going to be stored based on the hash code of the objects. Right, based on the hash code of the objects, it is going to be stored. The same concept of the hash table that we have seen here is being used as underlying data structure. Okay, so and then null insertion is possible. This is also important. So I can also insert the null elements, and this is also implementing serializable, clonable, and but not implementing the random access interface. Remember. So this is also important. Serializable, clonable, it is implementing and not implementing the random access interface. So you already know that what is the importance of random access interface. It means if anyone is implementing random access interface, if any object is implementing A random access interface, it means any element of that particular thing can be accessed with the equal speed. And then if it is implementing serializable interface, that state of that object can be stored in the flat file. And if anyone is implementing clonable interface, that object is eligible for cloning. It means you can get a duplicate copy of that. Okay, so there are 7 important points with regard to the hash set. One is first, underlying data structure. Insertion out is not present. Duplicate objects are not allowed. So if you are trying to add any duplicate objects, then what is going to happen? Neither you will get the neither you will get compile time exception nor the runtime exception, but it is going to return you false. It means you need not worry. Programmers' headache is very less here, right? And then heterogeneous objects are allowed. Null insertion is possible. Implement serializable, clonable interfaces, but not the random access interface, right? So now then, if you go to the constructors, you look at the constructors hash set h is equal to new hash set. So you will get the hash table, hash set with the capacity, initial capacity as well. So if you look at the initial capacity, capacities are varying from one the collection object to the other collection object. Okay, default fill ratio is 0.7%. So we will also call this as fill ratio or load factor. Okay, it means 75% of the this object is filled, then its size is going to be increased. Right? How this is going to be increased? Yeah, you see. Now you have another initial capacity you can mention. So the third one is you can mention hash set h is equal to new hash set. You can mention the initial capacity and you can also give the fill ratio. Okay, so fill ratio you can mention here. Based on the fill ratio, it is going to improve or it's going to grow, right? How much it is to be grown, that depends on the fill ratio. And then last fourth constructor is asset is equal to new asset of collection object. Directly, if you have any collection object, like if you have array list with you, you can directly put in the hash set. Okay, so you mention that collection object inside this. Okay, directly you can put a hash set. You can pass the hash set as an argument to the. Sorry, you can pass a array list as an argument to the hash set, or you can, if you have an array, you can pass that as an argument to this constructor. So if you have a stock object, you can also pass it as an argument to the hash set. So any collection object, you can pass an argument to this constructor, so it's going to be constructed with the that particular object. Okay. Apart from that, you can also have the other elements. Okay. Directly, if the data is available in the form of a collection, so directly you can put it as an element. Now you see, we have an example here. So hash set h is equal to new hash set. So h dot add of 3. Add method is very this is usual. This is used from the collection interface. The add method is to add an element to the collection, which is from the collection interface itself. Okay. So here we are adding elements, and then as we have seen in the previous previous slide, so you can see heterogeneous objects are allowed. Yes, so heterogeneous objects are allowed. Heterogeneous objects are allowed. 4 string objects are there. So one is another heterogeneous object. So null insertion is possible. Yes, null objects can be put inside. And then you can see, so I am trying to add a duplicate object here. Then it is returning what? A false value it is returning. But it is not showing any compile time exception or runtime exception. So what it is saying, just it is going to return you false. It means you cannot add the duplicate object at all. Okay, that's the meaning. And then if you see system.out.println of h, you can see all the elements. So null is first shown as a first element. The second element is, it's not the index based. You can see here. So next, second element that is stored is D, third element B, the fourth element C, and the fifth element N, and then last element Z. So in which way it is storing the elements? Based on the hash value, because the hash value of different objects are different. So that is assigned by the JVM. So that's why based on the hash value, the objects are going to be stored in this collection object. Okay. And you see, as a subclass of this, you have the linked hash set. This is only all the properties that I have explained for the hash set is also there for the linked hash set. Now both the properties of linked hash set and the hash set are same. Only the difference is I'll tell you there are three differences between hash set and linked hash set, but the remaining is everything is same for the linked hash set and hash set, except the three that you are seeing here. Underlying data structure for the hash table is hash set is hash table, whereas the underlying data structure for the linked hash set is combination of linked list and hash table. Remember, combination of linked list and hash table. Okay, so both are used for implementing linked hash set. And the second is insertion order is not preserved in the linked hash set, whereas in the hash set, whereas in the linked hash set insertion order is preserved. This is only the difference. See here, for any if you take any collection object in under the set category, so the insertion order is not preserved because it is following the hashing technique. So that's why the insertion order is not preserved. So, but if you look at, so here the insertion order is preserved. Where linked hash set, this is very important in the examinations and interviews point of view. They will ask you what is the difference between. So they will describe that. So for any set implemented classes, so the basic properties are. So what are the basic properties for the set implemented classes? Insertion order is not preserved. Duplicates are not allowed. So, but only one class where the insertion order is possible is insertion order is preserved is linked hash set. But the remaining all so the same. But it is linked hash set is introduced in 1.4. So hash set is introduced in 1.2. Yeah. Okay. Yes, ma. Have you understood this? So if you see, if I replace the hash set, I mean in the previous example. So if I put in place of, in place of hash set, if I put linked hash set, so I will see the different result. What is the results? You can see here, B, C, D, Z, null, temp. Okay, so where the insertion order you can see here. So it is B, C, D, Z, and null value will come after that. So because null is also a string. Null is a kind of string, right? That's why it is following the Z. And after that, so other 10 value is stored. Okay, so have you understood what is the difference between linked hash set and hash set? So for any set implemented classes, so the properties are, there are 7 properties. So in that the most important is duplicate objects are not allowed, and then insertion order is not preserved. But whereas in case of linked hash set, insertion order is preserved. Now the question is something like, what is the difference between hash set and linked hash set? So the answer should be what? The first point should be what? So the underlying data structure, it is okay, later you can write. The first point should be what? Insertion order is not preserved in hash set, whereas insertion order is preserved in case of linked hash set. Remember this point. And the next thing is, you can see the linked hash set demo here. So this is in place of hash set, I am using linked hash set, and here you can see B, C, D, Z, null, temp. Okay. So where exactly you can use the linked hash set is, so one application is cache applications. So while designing the cache memories inside the caching techniques inside the operating system, you can use these kind of data structures. Okay. So inside operating system, so several things are maintained in the form of data structures. Several data structures are there inside the operating system software. So while designing the caching techniques that you will see in the operating system, popular caching techniques are there. So for designing those caching applications, they use this linked hash set. Now you see, next interface is sorted set interface. So sorted set interface. So the basic purpose, this is the child interface of set interface. We have already seen this. So if we want to represent group of unique objects according to some sorting order, then you can use this sorted set interface. What is the purpose? It means you want to, my intention is I want to represent some group of elements in some order. based on my requirement, then I should use this interface. But what is the order? Sometimes if you are given some students, 10 students to you, so if I ask you to arrange them ascending order of the roll number, you can put them inside, but you can use this sorted set interface, right? So it means you can define your own way or the customized sorting order by using this. So generally, there are classes which exhibits the natural sorting order. So if you do not want the natural sorting order, you can make use of the sorted set implemented classes to define your own sorting order. So means the sorted set is meant for defining your own sorted order. Okay. So the sorted, the name indicates what is in the name sorted, right? It's going to sort elements. If you put an element inside that by using some techniques, it's going to sort the element. But what is the criteria for sorting the elements? So if you do not mention any criteria, the general criteria is what? Ascending order. Okay, if you mention a criteria for sorting the element, so then it can use that sorting there. So whatever is mentioned by you, and then it can sort the elements. Okay, you can see there are some 6 methods in this. So in the sorted set interface, you have the first method. So last method, head set method, sorted set method, tail set method, and then subset method, and then last at the end you have the comparator. Okay, there are 6 methods available. And you can see a program. I'm not showing any program. So how you can use these methods is you assume that you have elements. You have some 100, 101, 104, 106, 109, 110, and 120. And these elements are there in the collection object. In that case, if I want, so how I can use the method first. If I use the first, I will get the first element of this. These methods you can use on any collection objects which is implementing the sorted set. Okay, you can apply these methods which are implementing the sorted set interface. I will show you there is only one class that is implementing the sorted set interface, that is tree set. There is only one class that is implementing the sorted set interface, that is what? So that is tree set. You can see this order here. Once again, you can see this here. So the collection. So that's why I'm asking you to put this in mind. So collection, set, hash set, linked hash set. So the linked hash set is a subclass of hash set. And so another interface which is extending from the set interface is what? Sorted set. So as a sub interface of that, you have a navigable set. So a class which is implementing navigable set, sorted set is what? Tree set. So there is only one class which is implementing the sorted set. It means you can apply all these methods on the sorted set. Now you can see sorted set. Last element, if you ask, it is going to give you 120. So this method head set 109, it means it is going to give you the elements before 109. It means 100, 101, 104, 106. First 4 elements it's going to give. Next, a tail set. So tail set is going to return you the elements, the element that you mentioned here. So it means tail set of 109, 110, 110, 120, it is going to return. Subset 104, 110. So 104 and then 106 and then 109. So the boundaries. Okay, so the so this end point, this is n minus 1, remember. So its last element will not going to be considered. So this is exclusive. So 104 is inclusive and then 110 is exclusive. Comparator, it's going to return you null. So there is a special purpose for this. So now there is only one class which is implementing the tree set, that is the sorted set interface. That is what? Tree set. 1 second. For the tree set, the underlying data structure is balanced tree. Remember, the underlying data structure which is used to implement this tree set is what? Balanced tree. Okay. So there are several balanced tree, binary tree. Okay. These trees concepts you already studied. One of the balanced tree is there. The balanced tree is used as an underlying data structure for the tree set. Next, the properties anyway, duplicate objects are not allowed. So this is the set property. Insertion order is not present. Again, it is a set property. So heterogeneous objects are not allowed. This is the new thing. So in case of sorted set, I mean, in hash set and linked hash set, so the heterogeneous objects are allowed. But whereas in case of tree set, the heterogeneous objects are not allowed. Remember, what is the difference between tree set and hash set and linked hash set? Otherwise, what is the difference between tree set and the hash set? The hash set heterogeneous objects are allowed. In the tree set, heterogeneous objects are not allowed. Right? There is a reason for that. So if you are trying to add any heterogeneous objects into this collection, you will get the class cast exception. Remember, null insertion is also possible. Okay, null insertion is also possible, but only once. So about this null instance, I mean this null value. So if you want to insert the null value, you have to insert in the beginning. After inserting null value, if you add any other element, you will get the null pointer exception. Right. So after adding any other element, so if you are trying to add the null point, this null value, you are going to get the null pointer exception. Okay. Remember this. So null value can be added, but only you have to add it before you add anything. You have to add the null value before you add any value into this tree set. Otherwise, what you are going to get, I have added some 5 elements into my tree set. After that, if you are trying to add the null value, you are going to get null pointer exception. And again, if you have added null, first you have added null, and then if you are trying to add any other elements to the tree set, you are going to the null pointer exception. So only thing is, if you want to add a null value to this collection, you can add only null. You will not get anything. Only null you can keep in that. Right? So null cannot be compared with anything. Right? That's why only null value, after adding null value, first value you can add as a null value. Only first value. After that, if you are trying to add any other value, you will get the null pointer exception. First, for example, I don't want to add the null value in the beginning. So I have added some 4 elements into my tree set. And after that, if you are trying to add the null value, you will get the null pointer exception. It means if you want to keep null value, you can keep only null value in that, no other thing, right? But so maybe there is some uses of it by adding a null value to that. But you cannot do anything with one null value keeping inside the tree set, right? Almost we can say that null insertion is possible, but no use. Okay, but you don't write that. Null insertion is possible. Only that is the property. Next, you have the constructors here. So tree set is equal to new tree set. So this is a empty tree set, and then tree set is equal to new tree set of comparator C. And the third one is you can pass the sorted set interface, and then you can pass the any collection interface. So there are 4 constructors. One is empty constructor. So there are no fill ratios for this. It is also growable, but there are no fill ratios and all. So tree set, T is equal to new tree set. So you can, this constructor is very important constructor where you can pass the comparator object. I told you, so the basic purpose of sorted set is to define your own sorting order. So the basic purpose of the tree set is also to define your own sorting order, right? So by default, if you keep any element, if I keep 10 integers, by default they are going to be sorted. If I keep some 10 names, 10 strings, it is going to be by default sorted. So if I keep some 10 double values inside that, by default they are going to be sorted. So the basic nature of the tree set is to have some sorting order. What is the natural? I mean, if you do not mention, if you do not say anything to the tree set, it is going to arrange the elements in the ascending order only, right? But if you want to define your own sorting order, what you can do is you can pass the comparator object to the tree set. This is very important. So if you don't want any kind of the sorting order to be defined by you, then directly you add the elements to the tree set. By default, you are going to get the sorting order. The elements are going to be sorted based on natural sorting order. Natural sorting order Our default sorting order means what? That is the ascending order, right? And then if you have any special requirements, so tree set T is equal to new tree set of comparator object you have to pass. And then tree set T is equal to new tree set of any sorted set object if you have, you can pass that. That is also allowed. And then any tree set, I mean any collection object if you have, that also we pass to the tree set. You see an example here. I just created a tree set object. So it is available in the util package, and all the collection objects are available in the util mark. And T dot add of A and the small a, and then capital B, capital Z and L. And so tree dot add of new integer of 10. So see what is going to happen if I add heterogeneous objects. I should not add the heterogeneous objects to my tree set. The reason is because I cannot compare a string value and the integer. No, all the name. So the objects which are, I mean, all same kind of objects you have to put, because comparison becomes easy for the tree set to be put them in order. Okay. So I want to add only string objects. Yes, strings can be compared and displayed. I want to add only integer. There is no problem you can get, but you cannot add a mix of integer, string, double values, and whatever the objects that you want, you cannot add. So if you, because the heterogeneous objects are not allowed, if you try to add the heterogeneous objects, you are going to get class cast exception. Yes, ma, any doubt? Yes, ma. Somebody is trying to ask some doubt. Please, can you please respond, ma? Am I audible? Yes, ma. Yes, please. Guys, one of you please respond. Am I audible or not?
Yes, sir. You are audible.
Yes, sir.
Yeah. So can you answer? Do you have any question, ma? Yes. Do you have any question in this regard with respect to tree set, ma? Tree set is meant for what? Default sorting order or natural sorting order. So if you drop some elements into this, if you add some elements into this, you have to add only similar kind of elements, similar kind of objects or elements, whatever it is. We call them as elements or objects, no problem. So if you are trying to add any other element, you are going to get class cast exception. Remember this. So T dot add of new integer of 10. Now I am trying to add integer objects to this. Heterogeneous objects are not allowed. Why it is heterogeneous objects are not allowed? I cannot compare 10 and A, right? So that's why only similar kind of objects can be compared and not all, right? Remember that. And so here if I add T dot add of null, you will get the null pointer exception. But null insertion is possible, annam. Null insertion possible, null pointer exception is. So you have to write this T dot add of null means you have to write before you write anything. Add చేయాలనుకుంటే మొదట్లోనే null add చేయాలి. Null add చేసిన తర్వాత ఏది యాడ్ చేసినా null pointer exception వస్తుంది. ఏదైనా యాడ్ చేసిన తర్వాత null add చేస్తే you will get the null pointer exception. In any case you will get the null pointer exception. Okay? So that's why the null insertion is possible. But if you want to add the null value, you have to add in the beginning. After adding null value, but you should not add anything, Mali. So that's why it is null pointer exception. Now you see system.out.println. So just commented, these two lines are commented here. That's why, so A, B, L, Z, A. So on what basis it is sorting the elements? Maybe it is the ASCII value of it and then sorting it out. Okay? Yes, this is natural sorting order. It is okay. This is not the important at all. Okay, because its basic nature is to sort the elements. Right? You see here. Null, this is all okay. The same thing I have listed here. Next, you see another example. Here I am trying to add different kind of elements, right? You see in the tree set what I am adding. Yeah, so there is one important point that I want to highlight here. You see my tree set, inside the tree set I told you that only similar kind of elements are allowed. That's real. And but that similar kind of element like tree set. So here I am trying to add the string buffer objects. Now you see one important point is, so if you see the hierarchy of the wrapper classes and the string classes are implementing the comparable interface. Remember, there is an interface called comparable interface in java.lang package. There is an interface called comparable interface in java.lang package. Okay, any object that is implementing comparable interface, then those objects are comparable, right? So when we can say that the two objects are comparable, when those objects are comparing, those objects are implementing comparable interface. All the wrapper class objects are implementing comparable interface, and at the same time, so this string objects are also implementing comparable interface. So then, if you add the string objects to this tree set, because they are comparable, then it is going to sort them out. So next, if you are these string buffer objects are not comparable, what does it mean? They are not implementing the comparable interface which is present in java.lang package. That's why they are not comparable. Only criteria ఏంటమ్మా ఇది comparable కాదు object అని చెప్పడానికి. So in some sense you are thinking that the objects are also comparable. వీటిల్లో కదా కంటెంట్ స్ట్రింగే కదా ఉండేది. స్ట్రింగ్ బఫర్ లో కూడా కంటెంట్ స్ట్రింగ్ కంటెంటే కదా. Why can't we compare those items and why we can compare the string objects? Only thing is string object comparable interface implement చేసింది. That's why they are comparable. The string buffer object is not comparable. So not comparable because they are not implementing the comparable interface. That's the reason. Wrapper classes are comparable or not comparable? Yes. మనకు అనిపించడం కాదు comparable not comparable. ఇప్పుడు 10, 20, 30 even can you compare them? Because they are integer classes implementing what? Comparable interface. In fact, all the wrapper class objects are implementing what? Comparable interface. But the string buffer objects only implement చేస్తున్నాయి. Which are the classes implementing comparable interface? First class is what? So the string class is implementing comparable interface. And then all the wrapper classes are also implementing comparable interface. Then these objects can be put, right? So then if you add any string objects to the tree set, because they are comparable. So then some natural sorting order, by default they are going to be arranged in sorting order, right? If they are not comparable, when you can say that something is comparable? If they are implementing comparable interface. If they are not implementing comparable interface, you cannot compare that. Those objects, what you will get there? If you try to add them to the tree set, what is going to happen? If I add the student objects to my this tree set, what is going to happen? So the tree set doesn't know how to compare. Okay, tree set doesn't know how to compare them because these are not implementing what? Comparable interface. By default, the string objects and the wrapper class objects are implementing comparable interface. That's why if you keep them inside the tree set, for those objects, it is displaying in the natural sorting order. Okay, so if you keep the string buffer objects inside the tree set, right? So the string buffer is not implementing comparable interface. That's why this cannot be compared. That's why it is showing what? So the java.lang. So string buffer cannot be cached to lang. So java.lang comparable. It means what? So because the string buffer is not implementing comparable interface, so that's why it is not so comparable. That's why you will get which exception? Class cast exception. Remember, right? So this is a runtime exception. Remember, runtime exception. It is like arithmetic exception only, right? And you see here what you can do is so you can see the explanation here. If we are depending on natural sorting order, compulsory the object should be homogeneous and comparable. Otherwise you will get the class cast exception. Comparable and enti, it has to implement the comparable interface and the object should be of same kind. Okay, so because if you see integer objects and string objects are both are comparable, right? Because they are implementing comparable interface. Can I compare an integer object and the string object? No, because object should be what? The second condition is what? So there is an and condition here, homogeneous and comparable. Then only you will get the sorting order. So then only your objects will be sorted in the tree set. Otherwise it is not. Okay. And the second point also, which I have told you, you can see here. So an object is said to be comparable only if and only if the corresponding class implements the comparable interface. An object is said to be comparable if and only if the corresponding class implement the comparable interface. String class and all wrapper classes implements comparable interface, but the string buffer doesn't implement comparable interface. Hence, in the above program, we are getting what? Class cast exception. Right. Now you see, what is a comparable interface that is present in java.lang package? What is the comparable interface which is present inside the java.lang package? First, I will brief that, and then we have another advanced comparator object. Later, we will see that. Comparable interface present in the java.lang package contains, it contains a method called compare2 method. Right? So, in java.lang package, comparable interface is available, and it has only one method, that is compare2 method. Right, what the comparator is going to do, you can compare two objects by comparative method. You can see example here. You can see the example here, ma. Yeah. So how I can compare object1 dot comparative of object2. Right. Object, I am comparing object1 and object2. So if the requirement is, it is going to return false. It is going to return a negative value if object1 has to come first. The object1 has to come before object2. It means, so if the order is object1 comma object2, then it is going to return -1. If I something like, if I give the 10 compared of 20, so what is the value that is returned? One, a negative value will be returned. It means because those are in order, like you see. So assume you have an integer object 10 here. I am comparing this with another integer object 20. Right. So what is the order of the elements? In the natural sorting order, 10 comma 20. 10 comma 20. So if this is the order, okay, then it is going to return. I mean, so because you are comparing 10 with 20, so 10 should come first and 20 should come next after 10. So then in this case, it is going to return a negative value. A negative value will be returned. And you can see returns positive if object1 has to come after the object2. Okay, and if the order is object2 comma object1, then it is going to return a positive value. Right. So returns 0 if both the objects object1 and object2 are equal. Right. This is actually the comparative method implementation given in the comparable interface. What it is doing, object1 dot comparative of object2. So if you want, so if the no, not your requirement. So if the object1 has to come before object2, then it is going to return a negative value. If object1 has to come after the object2, it is going to return a positive value. If both object1 and object2 are same, then it is going to return the equal. Return the 0 value. Okay, it means, so if they are in the order, correct order, so 10 comma 20, object1 comma object2, 10 comma 20, they are in order. So it means it is returning a negative value. Okay, ascending order, it is returning a negative value. So the reverse order of the ascending order, it is going to return you a positive value. If both objects are same, then it is going to return a 0 value. I will show with an example, don't worry. You see here, system.out.println a dot comparative of z. What is this a? What is the order of, if I give you to sort the elements a comma z, what is the order? A comma z only. Then in that case, some negative value is going to return. So a comparative method is going to return negative if they are in order. Whatever the values that you mention is in order. Order and or this is object1. Remember the order. So this is object1 and this is object2. Okay. So if object1 dot comparative of object2, okay. So what is the order of this? First time రావాలి వీటిల్లో A రావాలి, ఆ తర్వాత Z రావాలి. So correct order కదా? If the order is this, if your order is so A comma Z, it is going to return a negative value. So reverse, you can see if I ask z dot, so double quote z dot comparative of k. In this case, so what is this? This is reverse of the natural sorting order. It means z comma k. The order is what? Z comma k. Then in this case, it is going to return you some positive value. Remember, it is a positive value. Either so number you forget. It should return some positive value. Again, if I say a comparative of a, it is going to return 0. A comparative of z, a comparative of z, it means the order is what? A comma z. If I give a comma z, what is the order? Correct order? A comma z. In this case, it is going to return a negative value. So z dot comparative of k, what is the order actually here? K comma z, but here it is, I mean, if you mention z comma k, then it is going to return a positive value. That's what you can see the description here. Returns negative if and only if object 1 has to come before object 2. Returns negative if and only if object 1 has to come before object 2. Returns positive if object 1 has to come after the object 2. Okay, so this is the natural definition given in the comparative. Right? For example, I'll if I write something like integer I1 is equal to some 20, integer I2 is equal to some 30. Okay, then so I1 dot comparative of I2. What is the value that is going to return? Tell me, ma. I1 dot comparative of I2. I1 is 10, I2 is equal to 20. In this case, what is the value that is written by the comparative? You tell me. I1 dot comparative of I2. I1 is 10, I2 is 20. What is the value that is written by the comparative method? Ma cheppali. So see, integer I1 is equal to integer wrapper class object anukondamma. Integer I1 is equal to 10. Integer I2 is equal to 20. Right? So now I am applying this data to the comparative method, which is available in the java.lang package. So so I1 dot comparative of I2. Then what is the value written by this? ఏది ముందు రావాలి 10, 20లో object 1 dot comparative of object 2 లో if object 1 has to come before object 2 అయితే ఏ వాల్యూ రిటర్న్ అవుతుంది? Emma, yes, which value is going to be returned? A negative value is going to be returned. If I say, so integer I3 is equal to 30, integer I2 is equal to 20. If I write if I write I3 dot comparative of I2, what is the value that is returned? I3 is 30, I2 is 20. If I compare this way, first పెద్ద వాల్యూతో చిన్న వాల్యూ కంపేర్ చేస్తే పాజిటివ్ వస్తుంది, చిన్న వాల్యూతో పెద్ద వాల్యూని కంపేర్ చేస్తే నెగిటివ్ వస్తుంది. ఐ థింక్ దిస్ ఈస్ నౌ క్లియర్, రైట్? చిన్న వాల్యూని పెద్ద వాల్యూతో కంపేర్ చేస్తే యూ విల్ గెట్ ఏ నెగిటివ్, పెద్ద వాల్యూని చిన్న వాల్యూతో కంపేర్ చేస్తే యూ విల్ గెట్ ఏ పాజిటివ్. ఈ మెథడ్ అలా రిటర్న్ చేస్తుంది. అర్థమవుతుందమ్మా? ఓకే, సో ఈ మెథడ్ ఏం చేస్తుందంటే ఇట్ రిటర్న్స్ 3 values. One is a negative value, the second one is a positive value, third value is a 0 value. ఎప్పుడు 0 రిటర్న్ చేస్తుంది? If I give 2 equal values, it is going to return 0. Okay, so now you can always remember object 1 dot object 2, object 1 dot comparative of object 2. సో ఇక్కడ ఆబ్జెక్ట్ 1 లో చిన్న వాల్యూ, ఆబ్జెక్ట్ 2 లో పెద్ద వాల్యూ ఉంటే then it is returning minus negative value. ఆబ్జెక్ట్ 1 లో పెద్ద వాల్యూ, ఆబ్జెక్ట్ 2 లో చిన్న వాల్యూ ఉంటే అది నెగిటివ్ వాల్యూ, ఆ పాజిటివ్ వాల్యూ రిటర్న్ చేస్తుంది. You remember this and then we continue our discussion tomorrow. Okay? Oh, there are only 57 students now. Okay, some exception is coming out. Yeah, guys, respond your roll call. Guys, respond to roll call. So 1832,
Present, sir.
181.
Present, sir.
Next, 1 second, ma. 1 second, ma. Yes, guys. Can you please respond? Can you please respond, ma? So roll number 121.
Present, sir.
Roll number 1,
Present, sir.
2,
Present, sir.
3,
Present, sir.
4,
Present, sir.
5,
Present, sir.
6,
Present, sir.
7,
Present, sir.
8,
Present, sir.
9,
Present, sir.
10. Roll
Present,
number
sir.
10, 11, 11,
Present, sir.
12,
Present, sir.
13,
Present, sir.
14,
Present, sir.
15,
Present, sir.
16,
Present, sir.
17,
Present, sir.
18,
Present, sir.
19,
Present, sir.
20,
Present, sir.
21,
Present, sir.
22, 20,
Sir.
23.
22 present, sir.
It's okay, ma. 23, 23, 24,
Present, sir.
25,
Present, sir.
26,
Present, sir.
27,
Present, sir.
28,
Present, sir.
29, 29, 30,
Present, sir.
31,
Present, sir.
32,
Present, sir.
33,
Present, sir.
34,
Present, sir.
35,
Present, sir.
36,
Present, sir.
37,
Present, sir.
38,
Present, sir.
39,
Present, sir.
41,
Present, sir. 41.
42,
Water present, sir.
43,
Present,
40, 44,
Present, sir.
45, 45, 46,
Present, sir.
47, 47, 48,
Present, sir.
49,
Present, sir.
50,
Present, sir.
51,
Present, sir.
52,
Present, sir.
53, 53, 54,
Present, sir.
55,
Present, sir.
56, 56, 57,
Present, sir.
58,
Present, sir.
59, 60, sorry, 181,
Present, sir.
182,
Present, sir.
301,
Present, sir.
302,
Present, sir.
303,
Present, sir.
304,
Present, sir.
305, 305, huh? 306,
Present, sir.
yes. The absent is 23, 29, 45, 47, 53, 56, 305. Huh? Yes, you can give.